All right, first up to bat to prove triangle congruence is side, 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 and then side, angle, side. It's a longer lesson, so if you need to take a break, hit pause and go do your thing. Here we go. If all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using fewer parts. So in this case, we're going to talk about side, side, side. So just like on your reference sheet, you have to have all three sides that match up, and then you can say the triangles are congruent. So on the right-hand side here, we'll just match up the sides. If AB is congruent to DE, BC is congruent to EF, and AC is equal to DF, then I can say the triangle is congruent. So this is where you write your congruency statement from a few lessons ago. First triangle you can put in any order you want. I'm just going to go ABC. The second one, you have to match them up. Angle A matches with D, B matches with E, and then C matches with angle F. All right, proof time. If I check out the givens, I've got 1, 2, 3 givens. So I'm for sure going to have 3 reasons that are going to be given. And it's important that you mark up your diagrams as you go along with these proofs here. If you don't mark up the diagrams on the proof, you're not going to know what to put down for your last reason. All right, so first statement, PQ is congruent to ST. That's given. Mark it up. PQ, congruent to ST. QR is congruent to RT. That's another given. Mark it up. QR, RT. R is the midpoint of PS. That's our last given. All right, so if R is the midpoint of PS, then I know that this piece is going to be congruent to that piece. PR is congruent to RS, reason, definition of a midpoint. One of the old reasons from a few sections ago. All right, 5 is your congruency statement. It says triangle PQR is congruent to triangle STR by side, side, side. SSS, just abbreviate. All done. Number 2, we have 1, 2 givens. First one, JL is congruent to MN. Mark it up. JL, MN. K is a midpoint of JN. And K is also the midpoint of LM. Okay, that was given to us. And once again, I know this, guys. If K is a midpoint of JN, then I know that JK is congruent to KN. They said it right here. Reason is definition of midpoint. And that works the other way too, guys. If K is a midpoint of LM, then I know LK is congruent to KM. And same reason, definition of midpoint. However, the triangle is congruent. They are congruent by side, side, side. Next page. Number 3, we have 2 givens. This time your statements are blank, but we can do this. Put down the first given in the first statement. AC is congruent to AD. That's given. Mark it up. AC congruent to AD. Next given, CB is congruent to BD. That's also given. Mark it up. CB, BD. No more givens. Now is when you have to look at the diagram and figure out what else could I possibly mark congruent. In this case, I'm going to say AB is congruent to itself, AB. The reason for that, when you have something congruent to itself, that is your reflexive property. Your last statement is what we're trying to prove. I'm trying to prove that triangle ABC is congruent to triangle ABD. And how are they congruent? They're congruent by side, side, side. All right, on to the next, guys. Side, angle, side, just like your reference sheet. You have 2 sides and the included angle. Remember, that's the angle in between the congruent sides. of one triangle is congruent to two sides and the included angle of another triangle, then your triangles are congruent. All right, match up the sides. AB is congruent to DE. Angle B is congruent to angle E. And side BC is congruent to side EF. Congruency statement. First triangle, any order you want. I'm going to go ABC. Match up your angles. A matches up with D, B to E, and C to F. Remember, included means the angle in between the sides. Don't forget that. All right, I have two givens. First one, JM is congruent to NL, given, mark it. JM, NL. Angle JMN, oops, wrong one. Here's JMN, not that one. So, just so we don't get confused, let me take this off of here. JMN is congruent to LNM. That's that guy right there. And that was given to us. Third statement says, hey, MN is congruent to MN. That's your reflexive property. And how are the triangles congruent? They are congruent by side, angle, side. Now, if I went the other way, side, oh, empty angle, can't go that way, right? You can never skip empty angles when you're figuring out how they're congruent. So in this case, they're congruent by side, angle, side. All right, number 5, we have 1, 2 givens. AB is congruent to BC, that's given. Mark it, AB, BC. BD bisects an angle. It bisects angle ABC. So this line right here is cutting this angle in half. That was given to us. But what that does is it creates two congruent angles. That's what number 3 says. Hey, angle ABD is congruent to angle CBD. And that would be your definition of angle bisector. Number 4, middle piece, BD is congruent to itself. BD, that's your reflexive property. And the triangles are congruent by side, angle, side. SAS. Number 6, we kind of have, it's one given, but it kind of counts as two. It says V is the midpoint of WZ, and V is also the midpoint of XY. So first reason is given. Now mark it up. WV congruent to VZ, definition of midpoint. Angle WVX right here is congruent to YVZ right here. Those are vertical angles. XV is congruent to VY. Once again, that was your definition of a midpoint. So same reason as number 2. How are the triangles congruent? They're congruent by side, angle, side. Number 7, we have 2 givens. HI is congruent to GJ. Next one also, HI is parallel. Remember, we put little arrows there to symbolize parallel lines to GJ. All right, angles. Angle GJH right here is congruent to IHJ right here. Those are alternate interiors. Here's my set of parallel lines. These are inside, opposite side. Those are alternate interior angles. And number 4, HJ is congruent to HJ. That's your reflexive property. 5 wants to know how the triangles are congruent. They're congruent by side, angle, side. Next page. All right, directions. It says state whether the triangles can be proven congruent, if possible, by side, 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 or side, angle, side. Then you have to write your congruency statement. You will see a lot of these on the quiz. Take this section seriously. All right, 1, I can say side, angle, side. Congruency statement, first triangle, any order you want. I'm going to go Y, T, Q. And that is congruent to Y matches with K, T matches with P, and Q matches with C. Number 2, I can mark the middle piece congruent. So side, side, side is going to work. And now I'm going to go triangle ADC. Match up the angles. A matches with C, D matches with B, and C matches with A. Number 3. Now, you have to imagine these two triangles being separated, right? But before I separate these two triangles, I notice this bottom piece is the same length on both triangles. So I'm going to mark that piece congruent. So if I do that, now I can say the triangles are congruent by side, angle, side. First triangle, I'll go JMK. J matches with L, M matches with K, and K matches with M. Number 4, not congruent. Now, it looks like maybe side, angle, side, but remember, you cannot skip an empty angle. So you might went this way, side, angle, missing angle, crap, can't go that way. So you can never skip empty angles. This does not work. This is a no. Number 5, I can mark the middle piece congruent. Side, side, side is going to work. I'm going to go CFE. C matches with D, F matches with F, and E goes to E. On number 6, I can mark a couple things here, but I'm going to stick with the alternate interior angle. So I noticed that these outside guys are parallel, so I can mark my alternate interiors congruent. Inside opposite sides, these are alternate interiors. And then these triangles are congruent by side, angle, side. First triangle, I'll go JDA. J matches with M, D matches with E, A matches with A. Number 7, that's a no. Angle, side, empty angle, no good. Side, angle, empty angle, no good. You cannot skip empty angles. Doesn't work. Number 8, you can mark the vertical angles. So this will work for side, angle, side. I'll go triangle ABC. A matches with E, B matches with D, and C goes to C. All right, for your next proofs, to check these ones out when you have blank statements and blank columns, I'm going to let you guys check out the answer key online, but I'm not going to do these ones in class with you. As far as your quizzes go, you will not see one of these on the quiz. You'll see stuff more like you got to fill in a missing statement or a missing reason somewhere along the line. Goes for this page as well. Take a look at the last page now in your notes. It says using side, side, side in the coordinate plane. So given the coordinates, determine whether triangle PQR and XYZ are congruent. So basically what they want you guys to do is you got to do the distance formula 6 times for the distance in between each of the sides. If you forgot the formula, I'll put it on top of your paper for you. Distance equals big square root. Subtract the x's, square them. Add that with the subtraction of the y's and square those, right? So we did a bunch of this, so I'm not going to go through the distance formula. That is something that you should know by now. If you don't know, figure it out. Two triangles. You got PQR right here. You've got XYZ right here. And I'm just going to give you the answer for the distance formula. So just to recap, one quick one, then I'm going to give you all the answers. Distance from P to Q. Subtract the x's. 5 minus a negative 3 turns into a 5 plus 3. Subtract the y's. Negative 4 minus 7. And square it. If you typed it in correctly, that comes out to be square root 185. So all I did was just type in stuff underneath the square root, and it comes out to be 185. Just leave it like that. All right, QR comes out to be square root 34. PR square root 61. XY comes out to be square root of 185. YZ is square root 61. And XY is square root 34. Yes, it works. There's one set of congruent sides. There's another set of congruent sides. And there's your third set. Are they congruent? Yes, side, side, side. Congruency statement. I'll go PQR. And according to my results, P is going to match with Y. Q matches with X. Ooh, I forgot my triangle. And then R matches with Z. Number 2, once again, we've got two triangles. I'm going to give you the answers. PQ is square root 221. QR is 232. PR is square root 41. XY is 221. There's one set. XY is square root 82. And you can basically stop there because we don't have any sides that match up here. So this is going to be a no. You do not have 3 sets of congruent sides. That is it for your lesson on side, 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 and side, angle, side.